All right, checking out the radar. Today is Monday, September 24th, and we're going to look at the Florida radar in the Panhandle, the second one into the state from the west side, the second from the western border of Florida. So let's check that out. I don't have a cursor on my phone, so I'm using a narration and zoom feature. Oh, you can see the wind coming across it as they shrink the radar and then blow it back out. Still a few days away, so everybody's predicting it's going to the Florida Panhandle. So we're checking out the Florida radar. Right now is a great example of that wind wave that comes across when they release the blue energy. See, right now the blue is occupying both circles. You have that inner circle and that outer circle. When it's within the first circle, it is allowing the weather in. And as they shrink that blue, the energy that they put over it, it releases that energy, and there's a vacuum that takes place underneath, and that's what brings the wind wave across. And sometimes you'll see that wind wave come from multiple directions, like you'll have a north and a south. And you can see that energy going in towards the radar. This is a phenomena that is repeated every day. And it's a triangulation. So let's see what the other radars are doing. The one on the western border of Florida.
Sticky. It's so sticky.
It's sticky. You want to go wash your hands, honey? Oh, it's actually not. That one's in Alabama. It's not actually Florida. Oh, it's got some wind waves as well. You'll just might as well check that out. So as they pulse, they contract. They bring up. They allow energy in, they direct the jet stream, they create high and low pressure areas, and they shrink it here. It's the blue shrinks, and the wind comes across. You'll see that wave of energy come across the radar as they deplete the energy when they shrink it. So here, let's go again on the cycle. There, the blue is in the first circle, and which is low, and they're bringing it in because the blue's shrinking and the wind comes across. So it's a triangulating factor. Let's see what else we could see. It's still too far out to sea at sea, and they've got Dopplers out at sea, so who knows what they're doing there. Let's check out this radar. It's the one that's more on the bend of the Florida Panhandle side here. KTLH, Tallahassee. It's relatively small, shrinking it and then back out again. So if they kept it, the energy, when a hurricane approaches, if they kept the energy out to the second circle, out to here, they could stop a storm or make it seriously diminish it, especially if they're not feeding it with a feeder beam, which creates a path that heats the atmosphere and then actually further ionizes it as it rips electrons off the incoming weather, making it more intense on the back end. And they'll pass it off from one radar to another. Okay, really big. Well, almost really big. I mean, that blue can expand out even past the second circle. When it's within that first circle, they're allowing the weather to come in, the clouds to be up above you versus way up above you when they create this high ceiling, this high pressure. Yeah, so as it shrinks, you could see energy going in towards the radar. So I'm not quite sure what they're doing yet. I just see that they're pulsing. So we need to watch it over the next couple days, and then you'll see which one picks it up and where it passes it to, and you'll see the connection between the storm and the actual radar. So right now they're creating their high and low pressure areas. All right, bonjour y'all, Nola Butterfly here. We're checking out Helene. This is the last 24 hours. This is not the latest, but the last 24 hours up to a certain point. This is the best continental radar archive I have. It's pauljhurtado.com. It goes back years. You can check out what the radar was doing on any given day. Otherwise, it's hard to capture radar if you're not capturing it at the moment. So let me just do not disturb. Okay, so you could see the very strong blues that are pumping up here. That was creating a high pressure ridge, which pushes all the weather to the East Coast. If it's the East Coast, radars aren't blooming as hard, and they are not, kind of hard to see though right now with the clouds blocking the potential blooms. They could still have some blooms, but just not as hard, which helps create the pulsing. But now we're going to go check out the individual radar and see where it's going. It's actually going right into the Tallahassee radar, and you can catch the beam right here. It's going from northwest to southeast, and the eye is going into that it's not this beam here that we see, although I don't know what this one does. It's not the same one. It's a negative depression here. It's like a negative space. You can make out. You can make it out here. That little straight line going from 11 o'clock to about 4 o'clock on the clock, and I know that the radar, the blue around the radar here, is very, very small because they're letting it in, although you cannot see it with the clouds right now. Oh, you can see right there before the clouds get up. We'll catch that again. Before the clouds get up into it, there's very little blue, and there's 2 circles. All right, here's the outer circle, and then there's an inner circle. You can see the inner circle here, and there's very little blue. The blue does not go out to the second circle, so that means it's a low pressure. They're allowing it in. They could stop this thing. So what they're doing is committing a crime, actually. They're committing a crime, and they do this every hurricane. We have years of capturing it going into the radar, we have here, they're saying Florida residents in Hurricane Helene's path that didn't evacuate are being told to write their name and birth date on their arm. That is so sick. I don't want to say what that is because I don't want this video to be censored. But let's just say red rum, if you know how to put that backwards, that's what it is. They are red rumming these people. And we will keep track of this as it progresses, but it's going right into it. Here, let's go in storm relative mean velocity. And you'll see the red and the green. Thank you, Leonard Coleman, for pointing that out to me. The red and the green will get on its side, and the white that is between it will connect with the storm's polarities, and it'll pull it in. So right there you go. There's it's connecting with the storm, and it's the eye, that black dot hole there is the eye. It is being steered up the white part. Here it's trying to lock up with it. They basically, with the electromagnetics, send their polarities to connect with it, and then they can steer it. Then it just gets steered right into it. It's getting pulled up by the white. This is red rumming the poor souls that were not able to get out of the way. So I am praying for you, Florida, and we will definitely keep a watch on this as it gets closer, and we're going to capture this. We're going to capture this, and one day somebody's going to care. One community is going to care, and they're going to take the right people to task on this, because I can't do it all. I've been capturing this for years. I'm screaming into an echo chamber. I'm censored. I was harassed. It's coming right into it. This has got to stop, guys. But it's going to take a community that cares. A community that's had enough. And then they're going to come back and they're going to build back better with more whatever sustainable development crap, or 5G, or smart cities, or, you know, they inch it towards it. They always rebuild according to the narrative of climate change. And it's like false sustainability narrative is what it is. There she goes. God bless, and blessed be. Okay, guys, it's 6 in the morning. I just refreshed this, and for some reason it won't show what happens at KVAX. It's way past this. The storm is way past this radar, and yet it shows it. Okay, it goes towards Tallahassee. You can see it, and then it gets pulled, but it won't show you the rest of it. And yet, if you look here, you'll see the storm is way up here. It's got two. The polarities are like split amongst radars, and it's like multiple storms. So let's blow this up here. We had Tallahassee was here. In the center of the screen, Tallahassee. Then it was pulled up in here, but they're not showing. I'm going to do it one more time. KVAX. So you see it's fresh, and it will not. It's real small blue, so it's allowing it in. I mean, there's a hurricane coming, and there's a glitch like that. That makes no sense. That makes no sense. So they won't show us KVAX, which is on the southern Georgia border, on the Florida-Georgia border. So then we had JGX. Let's see. I'm trying to capture this on my phone because my laptop, I thought maybe I could get a different image from my phone than the laptop. Here's JGX. It's not quite going over that. Something else is pulling it. Now, JGX, you betcha, was also working on pulling it up, but it wasn't the direct feeder. Okay. It's like going, but something else is pulling it. So it was going into it, and then they passed it off a little more gracefully, a little less directly than they usually do. So JGX was central, was the one above the radar that's on the border. Sorry, I don't have a pointer on my phone, so I gotta kind of zoom in. It was this guy here in the middle, above the border radar of Georgia. So it's the one here in the, what is that, South Carolina. South Carolina radar on the border of South Carolina and North Carolina. GSP. Takes a direct hit. And boom, right over the radar. That's the guy. That is the guy. So we'll watch this a couple times and then we'll put it on storm relative mean velocity. See how much detail we can get on that red-green show. Boom. But then you, okay. Then you have another radar. I mean, this storm is massive. Boom, right over it. Okay. And catch the storm relative mean velocity. See how clean that is? Okay. Yeah, there's the alignment. And there's the white pulling it up. It's not very clean shot. It's kind of hard to make out if you don't know what I'm talking about. But the white that separates the polarities of the red and the green lines up with the eye and pulls it up. But not a very clean one. So the reach of these radars are even beyond the circle. I don't know how far beyond. And then I don't know what aerosols they've put along the way for the checks and balances of all of this. But this is what we have. And I'm going to share this. I don't want you to see where I'm pulling it out of, which of my messaging, so I'm going to make another video and edit this. But there were tornadoes in the mountains, guys. I'm not even sure where this was. This was shared with me today from off of Facebook. Since when do tornadoes come across mountains?
Just the result of natural processes and climate patterns, or was it manipulated? The circular blue flashes seen in this video are frequency transmissions from the NexRad network of transmitter installations. All available science evidence makes clear that atmospheric frequency transmissions can and do have a repelling effect on air masses, especially if and when the air masses have been seeded with electrically conductive nanoparticles. The brighter the blue flash from a frequency transmission installation, the more pronounced and powerful the repelling effect on any air mass or storm in the vicinity will be. Where there are no blue flashes, there is no transmission, thus no repelling effect, thus no resistance for a migrating storm. Translation: a migrating storm will be hindered from moving toward frequency transmissions and will easily migrate in a direction with no transmissions. So again, I ask, was Hurricane Helene's path and behavior just an act of nature, or was it engineered?
Well, Dane, I am so glad you asked, because this is where years of my work that people have tried to get to you, that in fact you did not start acknowledging and calling microwave facility towers on Eglin Air Force Base until my work was presented to you. This is where my work comes in, and it's not about my work, it's about the details that my work entails, and what we capture, that it's not just, like you say, a repulsion from the microwave facility towers, aka Doppler radar. It's not just the repulsion and then the going into the non-energized areas that we are seeing, but more specifically and more liability inducing, we see feeding of the storms by the individual towers that are not doing the repelling, like you say, that are actually depleted of these energies, but have a beam coming out of them that steer the storms right into them. And so that is the triangulating factor that your work is missing, and I'm surprised that you have not taken your research further into the radar, but I'm glad you are at least discussing the radars. But it's not just a repulsion effect and lack of repulsion effect. It is a direct feeding. And that feeding is an ionization as it strips the electrons coming through and intensifies the storm on the back end. Because further stripping of electrons creates further condensation nuclei for the storm. So it's an ionization that takes place and a feeding. And the Doppler's own literature says, do not point it in one direction too long, as it will have environmental effects. And we know what these environmental effects. Couple that with the cloud seeding, with the balloons that are in the area of the severe weather events the day before, adding their particles. And then you have events like in Vietnam, when they weaponized weather and Congress didn't find out about it for 10 years, and they took out the Ho Chi Minh Trail with just a few cloud seeding projects. It is a whole toolkit of climate change tools, problem, reaction, solution. So thank you, Dane, for pointing out some of what the radars do, but we beg you to point out the rest of it, which is the triangulating effect, which is the liability. And I don't know why this work doesn't go viral, and other people's work does, but it's time. And human consciousness is starting to realize that Doppler radar is the missing factor, because it's not just HAARP that manages the ionosphere, but these radars manage the troposphere, feed the storms directly and through repulsion and through feeding. Thank you, Dane. Alright guys, I wanted to capture it going actually into the radar, not just approaching. Here it is. The center of the storm goes over the radar directly, because that's what's pulling it. Every time. You can see the indentation there, north-south, 12 and 6 o'clock. That's as close to a beam as we're going to get. That lines up with the midline of the polarities. Every time. And there she goes. Alright, see it? Poof. Perfect circle going over it. Now storm relative mean velocity. The red-green show, Leonard Coleman. Thank you for that. The white is at 12 and 6 o'clock. That is between the polarities, and it is lining up with the polarities of the storm, the midline of the polarities of the storm, which is the eye. That's where it pulls up the eye. That's how it controls it. This is Tesla technology, guys. Rumble.com/user/Nola Butterfly. Go down to my Clear Skies conference presentation for all the details. Okay, we're gonna catch Mississippi. Storm relative mean velocity. It's 12 and 6 o'clock. The white's getting ready to pick up what's being passed off, like the Harlem Globetrotters passing off the ball, twirling it on their fingers and passing it off. That's what it is. The blue is getting small, saying, come on in, come on in. All right? And this is every time. Every storm, radar after radar. This is your climate change. And here it is in the Mississippi radar coming into it. Storm relative mean velocity. You have the alignment at 6 o'clock. And you can see the glitch 12 to 6 o'clock. Not the glitch, but not the glitch at 7 o'clock or 8 o'clock, but at the blue goes real small. And then there's that indentation at 12 and 6 o'clock. That's the line that is connecting with the eye of the storm and pulling it in. That's 2 radars in a row. Gets connected to and goes right over the radar. Oof. Yeah, this is the missing VAX radar. For whatever reason, Tallahassee was pulling it, but then something else pulls it. I believe it's KVAX. But ultimately, the one they allowed it to take a direct hit was in South Carolina, past Atlanta, at GSP. GSP, there we go. This one, poof, takes direct hit. And what about the one that was south of that by Atlanta? Let's look at that one, see what we could see. It does go into it, but it has a pull that is more direct. So, you know, if you're playing tug of war with someone, they might move to the left and then they'll move to the right when the person on the right pulls on them, right? So this was tug of war all the way. And one more. Let's look at the one on this middle border here. You see, because the storm is split up. It's here in South Carolina, but it's in the northernmost Atlanta, Georgia radar. Let's check that one out once more, FFC. Yeah, and you can make out the beam here. And that pulls some of it into it. The back end of it. As it goes into GSP. I bet you we could see a pass off. Possibly. Let's see if we could see the pass off. Is it aligned with the eye? Very sloppy white between the red and the green. Oh, yeah, it links up. You can see the link as it passes it off, just like Tallahassee did. Okay. Well, there you have it, folks. Hurricane Helene, that which we could capture. And I've been up off and on throughout the night. I didn't sleep well, and I meant to be up earlier capturing some of this, but apparently KVAX was not going to show me itself, so I'm glad I did get some sleep. All right. I hope everyone's all right out there. God bless y'all.
This is a unique little book covering a topic that is much overdue for teaching children about our environment. The title is Funny Clouds, A Chemtrail's Tale. written by Raphael O'Neil, illustrated by Sean Gautreaux, and printed by an Amazon company called Great Space. The story is about little Marie and her mom, who go outside to plant a tree. When they finish, little Marie looks up towards the sky to see strange clouds sprayed by jet aircraft. The story is told in rhyme and prose that can inform but also entertain a young reader. I recommend this book because it has an optimistic message without instilling fear. The story ends on a positive note about how responsible people will ultimately succeed in stopping chemtrails by spreading awareness and taking political action. This little book is a valuable tool for adults to educate their children on an extremely important environmental issue. Informed citizens know that chemtrails were described in House Resolution 2977 as an exotic weapon back in 2001. Concerned parents have a right to protect their children from dangerous chemical experiments in our sky.